Hi, I'm Cheryl Abrigo with the University of South Florida Tech Transfer Office. Today we're here with Dr. Stavros Vakalis, who is Assistant Professor in Electrical Engineering. Welcome. Thank you for joining us today.
Yes, thank you for inviting me.
No problem. So you work a lot in the wireless arena. Can you tell us a little overview of what your technology is involved in? I know some have autonomous cars, the background.
Yes, so I'm working on in the general area of wireless systems. More specifically, I would say most of my work is radar systems, and we're actually in our group, we're trying to build, let's say, better and more capable radar systems that, for example, can do better detecting a specific type of targets, can help us get maybe some additional localization capabilities. And also now that, let's say, you hear a lot about 5G, people are already talking about 6G, sixth generation communications. We're trying to get, let's say, our radars to communicate because we're running out of spectrum.
Okay. And how does this play into it? I know we were talking a little earlier.
Yes, actually, essentially the information that radar systems are using is the reflections.
Okay.
Right? And in this lab, we have what we call more of a control environment. Right? So if the reflections are information, let's say we can place a target right here, and this on the back is an absorber wall that can help us, let's say, minimize the reflections from the environment and just now focus on the target of interest.
And then on the other one that I was referring to, how does the technology, what is important about autonomous cars and the technology?
Yes, actually now for autonomous cars, I would say there are multiple challenges that are facing, and one of them is that, let's say, if they miss a target, that target can be, let's say, a pedestrian.
Oh.
Right? So yeah, we're trying to make better radar systems, right, that can do better detecting targets.
Okay.
Right? That's a main point. And the other one is now that we're thinking ourselves, okay, since you have a new vehicle that will have so many radar sensors, what if you try to use now these, let's say, radar sensing capabilities to actually position the vehicle in space?
Oh.
Right? So, yes, we are essentially thinking always of new concepts, right? And trying to take advantage of what's already out there, or sometimes we even build our own systems.
Okay, very cool. And what was it that inspired you to go down this path?
Yes, actually, I really like experimental research.
Okay.
And I would say radar combines many different things. So in our group, we're building, let's say, antennas, we're building hardware, right? We're building software as well, because if the radar is receiving the information, we need to do something afterwards with it, right? And that actually gives us a lot of room to play with, right? Come with new ideas, right? And yeah, in this lab also we can demonstrate. So it's not just science, right? For the sake of science, we're also doing application-based research.
Practical
use.
Okay. So to get your technology out to industry, which is our ultimate goal, what are the type of tools that you could use?
Yes, I would say, we're always looking for funded research. So yeah, we're writing proposals, right, to get more funding. That is, let's say, for technologies that we're still working on.
Okay.
And we need to do some verification, right, to get a good proof of concept. But also we have, I would say, some technologies that are at a higher, let's say, technology readiness level.
Okay.
So for that, we can also license them.
Okay.
Right? And always, let's say, yes, we're looking for collaborations as well, whether it is with industry, with the national labs, or with other universities as well.
Very cool. How many students do you usually have working with in your lab?
Yes, currently we do, in our lab, working here, we do have 4 PhD students and 2 master students.
Okay.
And 3 undergrads.
Oh, nice.
Or so.
We like undergrads.
Yeah. Yes, but I would say, we do lots of research.
Okay.
And yes, the students, they they have their own office, so they do analysis,
Mhm.
they derive equations, but also they come here in the lab and they actually put their work into practice.
That's great. That's great. Well, thank you for spending time with
Thank
us
you.
today. This has been very interesting, and hopefully we can get something going. Thank you for joining us on the Tech Transfer Office. We will see you next time.